Hello everyone, welcome back to the Rajoor Academy. This is Shivaprasad, and in today's class we are going to solve the strength of materials question paper of VTU December Jan 2024 examination. In this video we will go through each question step by step, discuss the correct procedure, important formulas, and also focus on how to write answers in the exam to score maximum marks. This session will be very useful for students preparing for upcoming VTU exams, makeup exams, and revision. So keep your question paper ready, take notes, and let's start the solution with question number 1.
Rajoor Academy. Grow with knowledge.
Define the following terms: Poisson ratio, modulus of rigidity, impact load, and volumetric strain. Here are the solutions for these questions. First one, Poisson's ratio. Then what is the Poisson's ratio? Poisson's ratio is defined as the ratio of lateral strain to the linear strain. Therefore, mu equals to lateral strain divided by linear strain. This is the formula. Second one is modulus of rigidity. Modulus of rigidity is defined as the ratio of shearing stress to the shearing strain within a elastic limit. This is the important while you are writing the definitions. Within the elastic limit, the word is very important to get a full marks. So modulus of rigidity is defined as the ratio of shearing stress to a shearing strain within elastic limit. Z equals to shear stress divided by shear strain. The next one is impact load. Impact load is defined as the force provided by the sudden load on a structural part instead of a constant and sustained force applied over a long period. These are simple definitions. Okay. Final one is the volumetric strain. Volumetric strain is defined as ratio of change in volume to the initial volume. EV equals to change in volume divided by initial volume. Okay. I hope you all know these formulas. So go through these formulas. This is a very important question and a repeated question. Even though in the makeup exam also this question is framed. So the second question is, the following data refers to mild steel tested on a lab, diameter of the specimen 25 mm. So we have to determine Young's modulus, yield strength, ultimate strength, percentage elongation of the specimen, percentage decrease in cross-section area, that area of specimen. So this is for a 10 marks question and a very simple question. First we have to write a given data. Okay, given D naught equals to 25 mm, length L equals to 300 mm, load P equals to 15 kilonewton, change in length delta L equals to 0.045 mm. Then load at a yield point 127.65 kilonewton, maximum load P max equal to 208.6 kilonewton. Then final length is 375 mm. Diameter at a failure is 17.75 mm. So we have to find Young's modulus, E, yield strength, sigma y, ultimate strength, sigma max, percentage elongation, percentage delta L, then percentage decrease in area, so percentage delta A. So first one is to find Young's modulus E, we have to know the area of the specimen. So A equals to pi by 4 into D square. D is the diameter. Pi by 4 into D is 25 mm. So pi by 4 into 25 square, we will get a 490.87 mm square. The stress sigma equals to force by cross-section area, right? So sigma equals to P by A. P is a load or a force, 15 into 10 raised to 3, because 15 kilonewton they given. That value we are converting in a Newton per mm square. So 15 into kilo, that means 10 raised to 3 divided by 490.87 is a cross-section area. In the previous step, we already calculated. After solving P by A, we will get a sigma equals to 30.56 Newton per mm square. Strain equals to delta L by L, change in length to the initial length. That's equal to change in length is 0.045, they given in a question, divided by initial length 300 also they given. After solving this, we will get a strain equals to 1.5 into 10 raised to minus 4. Therefore, Young's modulus E equals to stress by strain sigma divided by epsilon. Okay. This formula is derived from the Hooke's law. Stress is directly proportional to the strain. After rearranging the equation, we will get a E equals to sigma by epsilon. You all learn this in the regular classes. So the formula for Young's modulus, we have to know that E is equal to sigma divided by epsilon. That's equal to 30.56 divided by 1.5 into 10 raised to minus 4. After solving, we will get a Young's modulus E equals to 203.73 into 10 raised to 3 Newton per mm square. This is the solution for Young's modulus. Okay. Second one is to find a sigma y, that is yield stress. Sigma is equal to P by A. Similarly, sigma y equals to Py divided by A. Py is a load at yield point. 127.65 into 10 raised to 3 divided by area of cross section 490.87. After solving, we will get a yield stress equal to 260 Newton per mm. Third one is ultimate stress sigma max equals to P max maximum load divided by area. P max is equal to 208.6 into 10 raised to 3 divided by area is 490.87. After solving these values, we will arrive at a sigma max equal to 424.96 Newton per mm square. The percentage elongation, percentage delta L equals to elongation into 100 divided by initial length. Elongation equals to final length minus initial length. So final length minus initial length divided by initial length into 100, we will get the formula. 375 is the final length minus initial length is a 300 mm divided by again the initial length is 300 into the percentage 100. After solving these all values, we will get a percentage elongation is 25%. Percentage reduction in area, final area minus initial area divided by initial area. So the values are 247.45 minus 490.87 divided by 490.87. That is the initial area into 100. We will get a 49.58% in terms of minus. That represents the reduction in area. The final area equals to, okay, pi by 4 into diameter at a failure square. We will get a 247.45 mm square. This is a very easiest problem for a 10 marks, a very basic concept. Sigma equals to P by A. Then Hooke's law, stress is directly proportional to the strain. Based on these equations, the examiner framed the question. Okay. Although if you have any doubt in this question, you can comment it. I will try to solve those problems. Next question, a load of 270 kilonewton is acting on a short RCC column of size 200 by 200 mm square. The column is reinforced with a 10 bars of 12 mm diameter. We have to determine the loads and the corresponding stresses on steel and concrete. They also given Young's modulus of steel equals to 16.5 times Young's modulus of concrete. They given P equals to 270 kilonewton, then breadth and depth B into D, both are same. So B equals to D equals to 200 mm. Then the Young's modulus of steel equals to 16.5 times Young's modulus of concrete. Total area equals to B into D, that's 200 into 200. We will get a 40,000 mm square. That's a total area, A total. So area of steel, AS equal to pi by 4 into 12 square, right? There are 10 bars. So into 10, that's equal to 1130.90 mm square. Therefore, area of concrete equals to total area minus area of steel reinforcement. Total area is 40,000 mm square minus area of steel is 1130.90 mm square. We will get a area of concrete equals to 38,869.1 mm square. The total load they given is 270 kilonewton. That load is acting on a concrete and a steel reinforcements. Therefore, PS plus PC equals to 270 kilonewton. Elongation in steel reinforcement equals to the elongation in concrete. Based on this concept, we can solve this problem. So elongation equals to PL divided by AE. Therefore, elongation in steel equals to load on steel into length of steel reinforcement divided by area of steel reinforcement into Young's modulus of the steel. Then the elongation in concrete equals to load on concrete into length of concrete element divided by area of concrete section into Young's modulus of concrete. Therefore, PS into LS divided by AS into ES, that's equal to PC into LC divided by AC into EC. The steel reinforcements are reinforced in a concrete section. Therefore, the elongation of both the concrete and the reinforcements are same. Hence, we taking elongation in steel equals to elongation in concrete. So, after simplified this equation, we will get PS equal to AS into ES into PC divided by AC into EC. Okay, this is just a rearranging of these terms. We know that area of steel 1130.9 into Young's modulus of steel, they given 16.5 times EC into PC is as it is because we don't know the value of PC divided by AC is 38,869.1 into EC is as it is. So after cancelling Young's modulus of concrete, we will get a PS is equal to 0.48 PC. So 0.48 PC plus PC equals to 270 kilonewton. This is from the equation number 1. The equation number 1 represents PS plus PC, load on steel reinforcement plus load on concrete section, that's equal to 270 kilonewton. So just we calculated load on steel equals to 0.48 PC, right? So now we resubstitute the PS value as a 0.48 PC. We will get a 0.48 PC plus PC, that's equal to 270 kilonewton. 1.48 PC is equal to 270 kilonewton. After solving, we will get a PC is equal to 182.43 kilonewton. The load on the concrete section is 182.43 kilonewton. Similarly, the load at the steel reinforcement 0.48 PC, we know the value of PC. So 0.48 into 182.43, we will get a 87.57 kilonewton. This is the loads on a concrete and steel sections. Okay, if you have any doubt in this question, you can ask those questions in a comment section. Now we have to calculate the stresses on steel and the concrete. So sigma C is equal to TC divided by AC, that is the stress is equal to load by area. Stress on a concrete equal to load on concrete divided by area of concrete. That is equal to 182.43 into 10 raised to 3 divided by area of concrete section is 38,869.1. We will get a 4.69 Newton per mm square. The stress on steel equals to load on steel divided by area of steel. That is equal to 87.57 into 10 raised to 3 divided by 1130.90. We will get a 77.43 Newton per mm square. These all are the stresses on a steel and stresses on a concrete element. If you calculate these values, you will get a 8 marks. Okay, these are all about question number 1 A, B, C. Let's move on to the question number